All right, now for the lab. By way of demonstration, I'm going to write down 3 points that I just made up. Now these points may or may not be on the same circle that I took your points from. So I'm only doing this for reference. So here's my 3 points. -2, comma 9. That's my next point. 5, comma 8. And then 5, comma 2. That's always nice when two of the points share a coordinate. That means they're either vertical with each other or horizontal with each other, and that's very nice. Okay. Um, Oops, I didn't mean to hit that button. Let me minimize this. Okay. In class, you were given or chose 3 points. There they are. In the order that you chose them, call them A, B, and C. So I'm going to call this one A, B, and C. This is just so I can generalize the directions for anything, for any points that you're given. Um, and on graph paper, you will include, on a graph paper, you will include with your results and calculations, mark those points and connect them to make triangles ABC. So you're going to have a graph paper, and on the graph paper, you would want to graph these 3 points if this were your points. So -2, comma 9. So there's A, 5, 8, there's B, and 5, 2, there's C, and I'm going to connect them. Boom, boom. All right, there's my triangle. Not the best picture, but that's what I would want. Okay, that's your first page. Using the midpoint formula, find the midpoint of each side of the triangle. So we're going to try to find the midpoint of AB. What's the midpoint formula? It's the midpoint is the average of the x's, which you find by adding up two x's and dividing by 2, comma, the averages of the y's. And I can do this pretty quick. So for the midpoint of AB, I'd take -2 plus 5, divide that by 2, and that'll give me the midpoint in the horizontal. And the coordinate for the midpoint in the vertical, 9 plus 8, divided by 2, means it's going to be at a height of about 7.5, not at about, sorry, 8.5, 8.5. And then this one's going to be 3 over 2, which is 1.5. So the midpoint of this will be over 1.5 and up 8.5. And that'll be the midpoint of AB. Find the midpoint of each side, showing necessary calculations, and add each midpoint to your graph. So each of those midpoints I'm going to add to my graph. All right. So I'll find all three using that technique. Average of the x's, average of the y's will be the midpoint. So this is midpoint of AB. All right. Find the slope and equation of the line connecting each side of the triangle, showing all of those calculations. So this will take a bit of room. I want you to find the equation of the line, the slope. First you got to find the slope and then find the equation of the line connecting these 2 points. So I'm going to demonstrate this with AB, -2, 9, and 5, 8. So let me add a new page. -2, 9, and 5, 8. I'm interested in the slope and the equation. So in order to do that, find the slope, I do slope is change in y over change in x. And you can use this formula where these will be your x1 and your y1, these will be your x2 and your y2. So you'd have 8 minus 9 over 5 minus -2 is -1 over 7. And let's go back and see if that makes sense. Down 1 over 7. Ah, you can also count the blocks, right? Down 1 over 7 definitely has a negative slope there. Okay. Once I find the slope, though, how do I find the equation? Well, I use the formula that y equals mx plus b. This is one of the ways you can do it. I'm going to plug in one of my points as an x and y. So y is 9 when x is negative 2. And now I do some multiplication and some algebra. 9 equals 2 over 7 plus b. If I don't like the fraction here, I can multiply everything through by 7. 7 times 9 is 63. 7 times 2 sevenths is 2. 7 times b is 7b. Minus 2 is 61. And then I get 7b equals 61. So b would be 61 over 7, which means my equation would be y equals m negative 1 over 7 x plus 61 over 7. Y equals mx plus b. M being the slope, b being the y-intercept. So this thing here should cross the y-axis at, and you can see why you wouldn't want to graph this by hand, because it's going to be very difficult to graph it by hand. But 61 over 7, that's a little less than 9. Let me use my green globs to graph this. I'm going to remove that. And we're going to put y equals, what was it, negative 1/7 x plus 61 over 7. Oh, and it's off the screen. So let me zoom out. I will, since I'm going to be up here in the top quadrant for the most part, I'm going to change this to negative 5. And, um, right, negative 5. And let's make this, that's fine where it's at. Oh, negative 5. And I'll go 10 there. Okay, boom. So there's my line. And you can see, does it go through the point? Look at where my mouse is at, down at the bottom. 2 comma, negative 2 comma 9? Yeah, it does. Does it go through the point 5 comma 8? Yes, it does. Okay. All right. So that's how you check it. When you're done, you graph it. Let's go back here. Let me check my time. Yeah. So that's how you'll complete that step. And you'll do that for each one. You find the slope and the equation of the line containing each side of the triangle. Let's stop there and I'll do the next one. Before I do that, note with me 3b. After we find the slope in the equation of the line containing each side of the triangle, so we find an equation for AB, for BC, and AC, use Green Glob's equation grapher to check your results graphed together, make the correct triangle. So all three of your lines should meet at those 3 points A, B, and C. If they don't, you don't have the right lines here, and you'll want to recheck your result. Um, but print out your results, write it right in the scale if not shown, and label the points. So, but you can do that. You know, you can copy paste that by doing print screen, copying into a Word document, and then you can have that all as part of your results when you're done. So anyways, I'll be looking for that graph by hand from part 1, your work for these parts, and then um, graphed with green globs, same triangle should be on the second page, but graphed with the computer. All right.